Imagine two identical wind turbines, side by side, yet one consistently produces more electricity than the other. What unseen factor could be at play, making such a significant difference? Air density plays a profoundly significant role in wind energy production. It directly determines the amount of kinetic energy available in the wind, thereby dictating how much power a wind turbine can generate. To understand this, we need to recall the kinetic energy formula, which is half times mass times velocity squared. In the context of wind, the mass refers to the mass of the air passing through the turbine's rotor area. Since mass is density multiplied by volume, a denser air mass contains more molecules, and thus more mass, within the same volume. Therefore, the power extractable from the wind is directly proportional to air density and, crucially, to the cube of the wind speed. This means if the wind's velocity doubles, the power increases by 8 times. But even a small change in air density can also have a substantial impact on power output. Air density itself is primarily influenced by 3 atmospheric conditions: temperature, atmospheric pressure, and humidity. Colder air is generally denser than warmer air. Higher atmospheric pressure means denser air. And surprisingly, humid air is actually slightly less dense than dry air at the same temperature and pressure, because water vapor molecules are lighter than the average molecules in dry air. For wind farm developers and operators, understanding air density is not just theoretical. They calculate the expected power output of a turbine based on the average air density at a given site. Turbine control systems can even use real-time measurements to adjust blade pitch and rotor speed, optimizing for current air density and maximizing power capture. This ensures the turbine operates at peak efficiency for the prevailing atmospheric conditions. When we discuss wind power, wind speed often gets all the attention, but air density is a silent partner, equally vital. For example, a wind turbine operating at sea level will produce more power than an identical turbine operating at a high-altitude site, even with the same wind speed, simply due to the higher air density at lower elevations. Engineers often use a standard air density value of 1.225 kilograms per cubic meter, which is representative of sea level at 15 degrees Celsius, as a baseline for their calculations. But real-world conditions always vary, and these variations directly translate to power output differences. By appreciating the critical influence of air density, we gain a more complete picture of how wind energy truly works. It highlights that optimizing wind power generation involves not only harnessing strong winds, but also carefully accounting for the subtle, yet powerful, effects of the atmosphere itself. This deep understanding is fundamental for designing efficient wind farms and advancing renewable energy technologies.